Right, this session we're working on standard form. Standard form now crops up just as likely on a non-calculator paper as it does on a calculator paper, so you need to be able to deal comfortably with them in both situations. With the questions I printed off, it's not clear from the WJAC site which were calculator questions, which were non-calculator questions. So I kind of guessed, or where it's possible to work without a calculator, I have done so, and where you need a calculator, I've indicated that. Before we start to look at the questions, I'll just talk to you about the way that I teach and structure standard form. You taught from primary school about place value with tens, units, hundreds, and so on, with a decimal point, which is your starting position. To this side of the decimal point, getting increasingly larger, you would start with units, tens, hundreds, thousands, 10,000s, 100,000s, and so on and so forth. But those can be written as powers, powers of 10, where that would be 10 to the power of 0. Anything to the power of 0 is 1. That would be 10 to the power of 1, 10 to the power of 2, 3, 4, 5, a million, 10 to the 6, 10 to the 7, and so on and so forth. And then when you came probably to key stage 3, you will have learnt that we've got place value to the other side of the decimal point as well, and you would have learnt that those were tenths, hundredths, thousandths, and then hopefully when you met indices you will have realised that that could be written as 10 to the power of minus 1, 10 to the power of minus 2, minus 3, minus 4, and so on in that direction. And so long as you know that and you can just write those out, then changing something to standard form is very, very straightforward. So if you have a number such as, let's go for 35,000, then if you write that under the place value, it would look like that. That means that you could write this number as 35,000 times 10 to the power of 0, or you could write it as 3,500 times 10 to the power of 1, or you could write it as 350 times 10 to the power of 2, or you could write it as 35 times 10 to the power of 3, or you could write it as 3.5 times 10 to the power of 4. All of those are correct. They all are different representations of the number 35,000. And in science, often numbers are written to 10 to the power of 3, so that they could write it as kilo, or 10 to the power of 6, which would be mega. But in general, the convention is for standard form that it's written as a decimal number between 1 and 10 times 10 to the power. So standard form, you write it like that. So the number 35,000, once you've written it into your place value grid, you can see straight away, well, it's in the 10 to the 4 column, but there's a bit more, there's half a thousand more again, so that's going to be 3.5 times 10 to the power of 4. Let's have a look at another one. Let's say we're going to do 4,750. So that's 4,750. It's going to be in the 10 to 3 column, so it's going to be 4 0.75 times 10 to the power of 3. The same thing works with smaller numbers. So if I've got 0.038, here's my decimal point. So 0.038. I could write that as 38 times 10 to the minus 3. Or I could write it as 3.8 times 10 to the minus 2. Or 0.038 times 10 to the minus 1. In standard form, same thing. It has to be a number between 1 and 10. So we're looking at 3.8 times 10 to the power of minus 2. So again, just like you're looking at what digit is in the most powerful place value, 3 times 10 to the 4, it's 3.5 times 10 to the 4. 4 is in the most powerful place value, so it's 4.75 times 10 to the 3. With this one, 3 is in the most powerful place value, so it would be 3.8 times 10 to the minus 2. The other thing that you need to know for standard form is, hopefully you've done a bit of work revising indices beforehand, and if you are multiplying powers, bases, numbers where the base is the same, so they're both 10 to the power of something, then you add their powers. So 10 to the power of 8 times 10 to the power of 2 is 10 to the power of 12. You could have negative indices. If you're multiplying, you add the powers. So that's going to be 7 plus negative 3, which is the power of 4. When you divide, if you had 10 to the 8 divided by 10 squared, whether you write divide as one over the other or using the divide symbol, doesn't matter. If the bases are the same, and all we're interested in standard form is tens, 10 to the power of 8 divided by 10 to the power of 2, you subtract the powers. So that's going to be 10 to the power of 6. For this one, if we were dividing those, when we subtract those powers, what you've got is 7 take away negative 3. So you've got two signs that are the same, which means they become an add. So you end up with 10 to the 7 plus 3, minus minus makes a plus, if that's how you remember it, to get 10 to the power of 10. So most of these things you need to be able to deal with if the standard form question is on a non-calculator paper. If it's on a calculator paper, your calculator does all that hassle for you. So what I would do when working with standard form is I would bang out very quickly one of those grids, as you'll see. If you don't think there's room in the question, use the back of the exam paper where you can carry on answering your questions. Okay, so let's take a look at these questions. Get the mark scheme ready. So find the value of 9.2 times 10 to the 5, take away, just zoom in a little bit, 3 times 10 to the 4. So that could easily be on a non-calculator paper. So what I would do is I would quickly get my number grid going. They're both positives. So if I get my decimal point going there, and then I got 10 to the 0, 1, 2, 3, 4, 5, 6, and so on. So 9.2 times 10 to the 5. means that the 9 is in the 10 to the 5, 2, 0, 0, 0, 0. So 9.2 times 10 to the 5 is actually the number 920,000. 3 times 10 to the 4, the 3 goes into the 10 to the 4 column, and then you complete the rest with zeros. So the sum that's actually wanting you to work out is 920,000 take away 30,000. So 0 take away 0, 0, 0, 0. 3 from 2 you can't do, so you got to borrow from there, so that becomes an 8 and that becomes a 12. 3 from 12 is 9 and 0 from 8 is 8. So the answer is 890,000. They want the answer in standard form, and you can read it straight off. It's times 10 to the 5, 8.9. Job done. So when we're adding or subtracting, that's the way we'll set it out. When you're multiplying or dividing, then you can separate these two bits out. So with this one, we're going to do 2.5 times 8 and 10.6 times 10 to the 3. That bit is what I was describing earlier. They're both to the power 10 to the power of something. So we're going to add those together. And 2.5 times 8. If we double 8, we get 16, and then we've got another half to go. So that's going to be plus 4 is 20. Okay, if you're not comfortable doing that in your head, well, there's nothing stopping you just going over there and saying, right, what's that? 5 8s are 40, 2 8s are 16, and 4, one number after the decimal point, 20. Doesn't matter how you do it, just make sure you can do it. So 20 times 10 to the 9 isn't in standard form. So 20 times 10 to the 9, if you imagine this continuing here, that's like saying, here we've got 92 times 10 to the 4. Well, 92 times 10 to the 4 isn't in standard form. 9.2 times 10 to the 5 is. So 20 times 10 to the 9 is going to be same as 2 times 10 to the 10. So if you left it in 20 times 10 to the 9, you wouldn't get the second mark. In standard form, that would be times 10 to the 9, so the 2 is in the 10 to the 10. This one we're adding. We're adding 10 to the 8 and 10 to the 9. So let's start our decimal point over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 times 10 to the 8. So we have a 5 there. 6.8 times 10 to the 9. 6 will be in the 10 to the 9. And we're adding those together. So these are all zeros. 5 and 8 is 13. 3 down, carry 1. 6 and 1 is 7. So it's going to be, the biggest digit is in the 10 to the 9. 7.3 times 10 to the 9. Okay, so it's not a huge faff to write that out, but you're more likely to get the answer right if you do so. Question 3. We're adding, so I'm going to send out my place value grid. (4.5 times 10 to the 8). there's the 10 to 8, 4, 5, 0, 0, 0, 0, 0, 0, 0. The 7, 9.4, 0, 0, 0, 0, 0, 0. And I'm adding those together. Zero, 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 4. 9 and 5 is 14. 4 down, carry the 1. 4 and 1 is 5. So in standard form, 5 times 10 to the 8, 5.44 times 10 to the 8. This one we're dividing. So we're going to do 6 divided by 3 is 2. 10 to the 12 divided by 10 to the negative 6 is 10 to the 12 take away negative 6, which is 10 to the 12. As I said earlier, the signs are the same. It's replaced with a plus, equals 10 to the 18. So that divided by that is going to be 2, which is the number part, 6 divided by 3, and then the 10 to the power is going to be 18. So we've worked with the number part, 6 divided by 3 is 2, then we've dealt with the power part and then combined them afterwards. The product of 1000 and 6 million. Product means times. So we're going to be multiplying these together. So first of all, we need to write these in standard form. So if I quickly knock out 1, 2, 3, remember you're only going to have to do this once in the exam. 1000 is going to be 1 times 10 to the 3. 6 million is 6 times 10 to the 6. So what you're going to be doing is 1 times 10 to the 3 multiplied by 6 times 10 to the 6. So the number part is 1 times 6 is 6. The power part is going to be adding the powers, 10 to the 9. So you're going to end up with 6 times 10 to the 9 is your final answer. So we've turned those numbers. First of all, you need to recognize what product means. It means multiply. Change 1000 into standard form, 1 times 10 to the 3. 6 million into standard form, 6 times 10 to the 6. And then it makes multiplying them easy because it's just 1 times 6 is 6. Base is the same, add the indices, add the powers. Question 4. Divide 6.3 by 12.6. Hopefully you can see, well, if I double that, I get that. So it's going to be 1 over 2, which is a half. So we got the 6.3 over 12.6 is 0.5. And then this is going to be 10 to the 12 minus 8, because we're dividing, which is 10 to the power of 4. So we got 0.5 times 10 to the power of 4. Well, if you think of that, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. 1 times 10 to the 4 would be 1, 0, 0, 0, 0. So 0.5 times 10 to the 4 means we got a 0, 5, 0, 0, 0. That's 0.5 times 10 to the 4, which is the same as 5 times 10 to the 3. because that isn't in standard form. It has to be between 1 and 10. So if you left it like that, you get 1 mark because you haven't got it in standard form. With this one, 8 times 3 is 24, times 10 to the power of 2 add 6 is 8. 24 times 10 to the power of 8, that's not in standard form. The 4 would be in the power of 8 column, the 2 would be in the power of 9 column, so that's the same as 2.4 times 10 to the power of 9. Not in standard form, in standard form. This time we're adding them, so we'll get our grid going. 10 to the 0, 1, 2, 3, 10 to the 8, so I've got 3.24. in the 10 to the 8 column, 1.2 in the 10 to the 7 column. And I'm adding those together. So I get 0, 0, 0, 0, 0, 0, 6, 3, 3, 3.36 times 10 to the 8. $13 million. So 13 million is going to be 13 million has got 6 zeros. I haven't given myself enough space now. So if I put underneath 10 to the 0, 1, 2, 3, 4, 5, 6, 7. 1.3 times 10 to the power of 7 is 13 million. Right, this one, it doesn't look very different from that one, apart from the fact that 2.9 doesn't divide nicely into 7.1 or the other way around. So this one would be on a calculator paper. So on your calculator, can I get light? There we go. It's not great. On your calculator, your standard form button is there, times 10 to the. So when you're going to write that on your calculator, again, you can type it in exactly as you see it. Use the fraction button to create the something over something, and then we're going to do 2.9. This is really annoying. There we go. So 2.9, and then we're not going to type in times 10 to the power, we use the standard form button. And it puts that in for us, so we're recognizing that's a standard form number, and then we type in number 12. So that's how the 2.9 times 10 to the power of 12 is represented on the calculator. Move your cursor down to the bottom, 7.1, standard form button, 4. So that pretty much looks as it's been written. So that is that hideous monster. So let's write that down. 4804507 0.42. We've got to give that in standard form correct to two significant figures. Well, if we deal with a significant figure bit first, the two most significant figures are that one and that one, because they're in the position of highest place value. So it's either going to be 40 followed by zeros, or 41 followed by zeros. And because that next digit is an 8, that means it's nearer to 41, 0, 0, 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6. and then we don't need to worry about anything after the decimal point. So that would be 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, 4.1 times 10 to the 7. So we could have written out the grid and then put it underneath, but I worked by saying that's 10 to the 0, 10 to the 1, 10 to the 2, and so on like that. So 4.1 times 10 to the power of 7. So with that question, if you had just written down that answer, you'd have got 1 mark. If you'd have written that answer, you'd have got 2 marks, because you've got insignificant figures, but you then need to turn it into standard form for the 3 marks. Calculator. The Millennium Stadium can seat 72,500 people. The population of Wales could fill the Millennium Stadium 42 times. Use this information to calculate the population of Wales. Give your answer in standard form, correct the 3 significant figures. Okay, so 42 times that is going to be the population of Wales. $72,500 times 42. So we'll write that whole thing down. So that's 3,045,000. So to 3 significant figures, these are the 3 most significant. So it's either going to be 304,000 or 305,000. Because the next digit is 5 or more, that rounds up. So that's going to become 305,000 to 3SF. Then we need to write that in standard form. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. So the 3 is 10 to the 6. So it's going to be 3.05 times 10 to the 6. So rather than writing out that grid, now I'm just going, well, there's the decimal point. So that's 10 to the power of 0. 1, 2, 3, 4, 5, 6. Stop. 3 to the times 10 to the 6. But it's not just 3 times 10 to the 6. It's 3.05 times 10 to the 6. Question 8, non-calculator probably. So the easiest thing to do here is to write them all in terms of standard form. That's in standard form, that's in standard form. This one is the same as 1 times 10 to the power of 3. And this one, 10 to the 0, 1, 2, 3. 2 times 10 to the 3 is 2.1 times 10 to the 3. So the smallest number there is that one, because it's got the negative power. Then the next smallest would be 1 times 10 to the 3. And then I've got these two. Well, that one is 2.1, that one's 2.4, that's going to produce a bigger number than that one. Okay, so it's important with questions like that you do a bit of work. You don't just guess and think, oh well, blah blah blah. You actually do the writing in standard form. With this one, we could write that out all the way up to 10 to the 13, but we know they're both times 10 to the 13, so they're just going to end up with zeros all the way along, and the 6 and 9 in the same column. So you're going to end up with 6 and 9 is 15 times 10 to the 13, but 15 times 10 to the 13, that's not in standard form. That's going to push us one further out, which is 1.5, into the next column, which would be 10 to the 14. So again, if you wanted to, you could write that out, but because I've recognized, well, hang on, they're both going to be in the same column, I can just add them and deal with it afterwards. Question 9. You could do that without a calculator, but certainly part B, you're going to need a calculator. So I reckon this will be on a calculator paper. So let's do it. Fraction, 3.6, standard form button, 7, move the cursor down, 6, standard form button, 4. So that's equal to 600. They want the answer in standard form, 10 to the 0, 10 to the 1, 10 to the 2. So that's what they're looking for. Okay, so let's take a look at part B. The mass of an atom of hydrogen is 1.66 times 10 to the minus 24 grams. The mass of an atom of oxygen is 2.66 times 10 to the negative 23 grams. A molecule of water consists of 2 hydrogen and 1 oxygen. Calculate the mass of the molecule of water. So 2 hydrogen, so we're going to be doing 2 lots of 1.66 times 10 to the minus 24 plus the weight, the mass of the oxygen. So that's what we have to work out. So let's type it exactly as I've written it. Open bracket, 2 lots of 1.66 standard form negative, and it's this negative button, not a subtract button. So it's 2 lots of 1.66 times 10 to the negative 24 plus 2.66 standard form button negative 23. So they want 2.9, so you've got 2.992 times 10 to the negative 23. They want 3 significant figures, 1, 2, 3. The next one over is less than 5, so we're just going to write down 2.99 times 10 to the power of negative 23. Question 10, this will be on a calculated paper. So we got to get this to 3 sig figs. Let's write it, type it in exactly as we see it. Fraction button, 8.44, standard form, negative 8, times 4.53, standard form, negative 4, and on the bottom, 2.34, standard form, 16. Press equals, and we get that big long string. So to 3 significant figures, first significant, second, third. Look at the next one along, smaller than 5, so we're going to write 1.63 times 10 to the negative 27. That question, I'm not entirely sure why they've given so much space, because you can do it all in one line on your calculator. And finally, the reciprocal of the speed of light squared is 2.22 times 10 to the minus 18. Find the speed of light in standard form correct to 2 significant figures. So you need to know what that means, and you need to pick that up. So if the speed of light, let's call it s for speed, the reciprocal of the speed of light squared is 2.22 times 10 to the negative 18. So the speed of light squared, reciprocal means 1 over. So what this is saying is 1 over the speed of light squared is 2.22 times 10 to the minus 18. So reciprocal means 1 over speed of light squared. So it's S we're trying to work out. Now, depends how you've been taught this. There's all sorts of shortcuts that you could do. I'll assume you don't know any shortcuts. So to get the speed on its own, the first thing I need to do is get it from underneath that fraction by multiplying both sides by s squared. Which means it's gone from under there and it becomes a multiply up there. Now to get that on its own, I need to get rid of the standard form by dividing. So you get that. Now you may be taught that, well, that's actually the same as that over 1, so turn both sides upside down and you get to the same place. Once we've done this, in order to get the s on its own, I've got to do the opposite of squaring, which is square rooting. So in order to find s, that's what I'm going to put in my calculator. And again, with these fabulous calculators, you can put that in exactly as you see it. So first of all, I've pressed the square root button, then I'm setting up a fraction sitting underneath it. It's got a 1 on top, and underneath 2.22 standard form negative 18 equals that horrible looking thing, which isn't in standard form. We want it in standard form corrected to significant figures. So let's write it to two significant figures first of all. 6 and 7 are the most significant. The next one has got less than 5. So it's going to be 6, 7 followed by 1, 2, 3, 4, 5, 6, 7 zeros. To take you to the decimal point. So for our standard form, 10 to the 0, 1, 2, 3, 4, 5, 6, 7, 8 is going to be 6.7 times 10 to the power of 8. So there you go, standard form practice.